Hello dear children, in this video we are going to discuss the top 10 numericals in a physics of class 10th. Children, board examination point of view, these numericals are very important and very useful to you so that you get idea what kind of numericals are expected in boards. And children, my advice is that, so whenever we start numericals, as you know that yes, a numerical is shown in on a screen, right? So my advice is that better pause the video, try the numerical, okay na? Then just you can watch the explanation. That is how actually you can have good practice. And don't forget to comment your answer. So 10 numericals, 10 solutions, and 10 times you need to practice, right? I mean not a same numericals, 10 numericals you should have a practice. So chalo, let us start the practice. Let us start together. Here I'll be doing, there you will be doing. Is it clear, children? Yes. So let us see the first numerical. This numerical is based on the lens, and it's one of my favorite numericals, because if you can see the numerical, children, they didn't mention whether it is a convex lens or a concave lens. But how to solve it? Yes, let us see here. So as per the numerical, first numerical, children, it is given that one lens, okay, it might be convex or concave, it is a later, okay. I am representing the lens with a vertical line. I don't know whether it is a convex lens or concave lens. And here is a principal axis, we are very sure. It is given that, children, here an object is placed at a distance 15 centimeters, okay, so that image is formed at a 60 centimeters in front of it. Here only some students will have a confusion. Front means they will think this side. No, children, front means what actually? Same side, because we will place the object in front of the lens. So in a question it is given that image is formed at a 60 centimeters distance in front of it. In front of means what? Same side, this side only. Here let us say some 60 centimeters. So as the image is formed same side, children, it is a definitely virtual image only, because real image is formed other side behind the lens. Okay, now I can say that here is virtual image but enlarged. Now here you may get a one doubt. Sir, on what base you can say that it is enlarged image only? Yes, I also can tell one more thing, children. I also can say that yes, surely it is a convex lens only. I am very sure. Now still you may get one doubt. Sir, on what base you are telling? Please tell to us also. Yes, look at, children, here. Concave lens forms virtual image, and a convex lens in the sixth case it forms a virtual image. But difference is there. Concave lens forms virtual image always in between object and lens only. Object and lens. Whereas convex lens only forms virtual image behind the object. So that is a clue. In a numerical it is given that image is formed at a 60 centimeters, so not in between. Hence it is a convex lens only. Now as per the sign convention, as these two measurements are left side of the lens, so object distance is minus 15 centimeters. Even image distance also, not focal length, image distance also minus only. Now they are asking us to find the focal length. Yes, so the first part of the numerical is focal length. Let us use the lens formula. 1 by f is equal to 1 by v minus 1 by u. Substitute with the sign convention. Minus 60 minus of it is minus 15. Minus into minus it is a plus. So 1 by f is equal to minus 1 by 60 plus 1 by 15. Children, let us take the LCM. It is going to be 60. It is a 60 ones, and 15 fours is a 60, right? So this is minus 1 plus 4. It is a 3 by 60. So here is 1 by f. 3 by 60 is how much, children? 1 by 20. As 1 by f is equal to 1 by 20, f is equal to 20 centimeters. Children, do we here we got a plus or minus? A plus only. We must get plus only. Why? For convex lens, focal length is always positive as per the sign convention rules. Now they are asking even to calculate the linear magnification. Children, linear magnification is equal to v by u. You may get one doubt, sir. We also have formula in terms of height, right? Yes, but here heights are not known. So we are using image distance to the object distance. So this is minus 60 by minus 15. So here we got m is equal to plus 4 only. Now they are asking us to write the characteristics of the image, children. So by knowing the sign and the value of the m, we can speak about the what we can say, characteristics and the nature of the image. Already anyhow, we know that it's a virtual image only, but still as a linear magnification is a positive, it is a virtual image. So for a virtual image, linear magnification is always positive. And m is equal to 4, which means what? M is greater than 1. Greater than 1 means what, children? It is a enlarged image. So it is a virtual and enlarged image. So this is a numerical 1. Okay. Now with the same spirit, with the same speed, with the same motivation, let us move to the numerical 2, children. So in this numerical, very clearly they mentioned that it is a convex lens only. So the question is that here is a convex lens. So they are saying that where object of 3 centimeters must be placed. So we don't know where this object is placed actually. So that one, what we can say, a screen is there here. So object means what here? Candle, they said. Okay, let us make the candle diagram to have the feel. Okay, so they are saying that yes, image is formed at 30 centimeters, means at a 30 centimeter distance one screen is placed. There a image is formed, and also given that the image height is 6 centimeters. So in order to get the image on the screen which is placed at 30 centimeters and whose height is 6 centimeters, where the object of 3 centimeters must be placed. To get this much size of the image at this much distance, where this object must be placed. Is it 30 centimeters or 20? Yes, it is 30 only. So in the question, there are 3 parts. They are asking us to calculate the u value, that is object distance, even focal length, and obviously linear magnification also. So as per the sign convention rules, children, here, so object height is given 3 centimeters, image height below the principal axis, so it is a negative minus 6 centimeters, and image distance, so right side, it is a 30 centimeters. They are asking us to calculate u value first. So we know this relation. What is the relation? Image distance by object distance is equal to image height by object height. So from this we can rewrite the formula. U is equal to, get this h naught hi this side, we will get reciprocal, right? So v into object height by image height. So image distance how much? 30, object height is 3, this is minus 6. So 3 ones are 3 twos are 30 by minus 2, minus 15. Yes, children, how much we got? Minus 15. Yes, object distance always negative. Why? Because it is placed this side, right? It has to be negative. Okay, fine. Now second part of the numerical, focal length they are asking. Same formula, 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v is equal to 30 centimeters minus object distance, how much we got? Minus 15. So minus 15, minus into minus plus. So 1 by f is equal to 1 by 30 plus 1 by 15. Let us take a LCM. It is a 30, 30 ones, 15 twos. So this is 3 by 30. 3 by 30 is how much? 1 by 10. As 1 by f is equal to 1 by 10, children, f is equal to 10 centimeters. So look at here. Here also we got focal length positive. Why? Because it is a convex lens. Here if you get a negative, then you should get a doubt. So you can think that yes, somewhere something went wrong. Like that also you can cross check in exam. Okay, fine. Now third part of the numerical, linear magnification. M is equal to, children, either you can use image height object height or image distance object distance. You will get the same thing. Let us check whether do we get the same answer or not. Image height by object height. Image height is minus 6, object height is 3. So you got a minus 2. Let us use the image distance by object distance. It is plus 30 by minus 15. So it is the minus 2 only. So any formula you can use, you get the same answer. As here you got a negative, yes, anyhow image is formed on the screen means a real image only. And it is a 2 means what, actually greater than 1. So it is an enlarged image only. Okay, children. So these are the numericals based on lens. Just copy that so that just we will proceed. Copy it. 3, 2, 1. Okay. 0.80. Children, This is a very special numerical. So with the single, I think in this single numerical, we have almost 4 to 5 variations. So if you can practice this numerical, almost you'll get a grip, so that you can do the rest of the numericals based on the current electricity. Okay, fine. So this is how actually the question is given. So here 2 volt, it is EMF, 2 ohm, it is internal resistance, and this ammeter. Generally for ideal ammeter there won't be any resistance, but practical ammeter resistance will be there. So let us say this is a resistance of the ammeter RA, and these are the external resistors. Let us say it is R1, here is R2. First they are asking us to calculate the ammeter reading, which means what? Current in the circuit. Children, remember one important thing. Whenever you want to calculate the total current in the circuit, you must calculate the total resistance. So now look at here, these two are in parallel, right? So let us first calculate the resultant resistance of these two. So this will be R1 into R2 by R1 plus R2. So this is going to be 4.5 into 9 by 4.5 plus 9. This is going to be a 13.5. If you can simplify, you will get it as a 3 ohm. Okay. Now total resistance I want. Total resistance. If you can see this RP, this ammeter resistance, internal resistance, these all are in series. So it is going to be internal resistance plus ammeter resistance plus the what we call the resultant of these two external resistors. So internal resistance how much? 2 plus 0.8 plus it is 3. So it is I think it is 1.2. Sorry, it is 1.2 is given, not 2. So 1.2. So this is going to be a 5 ohm. So this is a total resistance of the circuit. Now let us calculate the current. So current is equal to, we know that it's EMF by total resistance. EMF is equal to how much, children? 2 is given. Okay. Total resistance is 5. So hence 2 by 5 is how much? 0.4 ampere. So this is the total current in the circuit. Now the second question, children, they are asking us to calculate the potential difference across the terminals of the cell, which means what? Indirectly they are asking us to calculate the terminal voltage. So there is one specialty with the terminal voltage. What is that here? Whenever you are calculating the terminal voltage, children, it is total current into external resistance only. I mean, you should not consider the internal resistance. You should not consider the internal resistance. So first let us calculate this total external resistance. It is going to be how much? So let us not add this R value. So 3 plus 0.8 is how much it is? 3.8 ohm. I repeat once, whenever you are calculating the terminal voltage across the cell, we should not consider the internal resistance. Only when we are considering the potential drop, then only we have to consider the internal resistance. So we will see that also. So total current is 0.4 and this is 3.8. So how much you get? Just do it. It will be 1.52 volt. So this is a what we can say terminal voltage. Now third one, children, here let us even calculate the potential drop. Potential drop is equal to current into internal resistance only. Internal resistance only. Total current is how much? 0.4. Internal resistance how much? 1.2. So this is going to be 0.48 volt. And children, to cross check whether we got correct or wrong, you can do one thing. What is that? We know this formula, right? What is that? EMF is equal to terminal voltage plus potential drop. So if you can add these two, 1.52 plus 0.48, you must get the EMF. So 1.52 plus 0.48, it's 2 volt. Yes, 2 volt. That is what actually we got. Now next numerical, children, they are asking us to find the potential difference across 4.5 ohm resistor. Across what? 4.5 ohm resistors. Children, now what is this equivalent resistance? See, as these two are in parallel, the potential difference across 4.5 and across 9 both will be same. But here these two are in series, right? So this EMF, the what is the terminal voltage, whatever we got 1.52, get divided between this ammeter, because it is also resistor, and this also. So now this what we can say the diagram whatever is shown, I can make like this. So children, so this is one resistor, let us say ammeter resistance, it is given 0.8 ohm. So in the place of ammeter, I am just highlighting its resistance, and the combination of these two resistors is how much? It is 3 ohm. It is 3 ohm. Okay. Now let us name it as this is RA. Okay. For sake of R convenience, I am taking it as a R1 once again. Don't get confused. And here is a R2. So definitely now terminal voltage, that is potential, will get divided. Now they are asking us across 4.5. Children, across 4.5 or across 9. As these two are in parallel, potential difference will be same only. So we have one formula to calculate this. What is that here? V2 is equal to V into R2 by R1 plus R2. So V is what? Terminal voltage 1.52. 1.52 into R2 value is how much? 3. By add these two, 3 plus 0.8, it is 3.8. This is going to be 1.2 volts. So this is how we can calculate the potential difference across 4.5. Children, I repeat, as these two are in parallel, across this will be same. For suppose if they will ask you to calculate the potential difference across the ammeter, then what we should do? The total is how much? Total 1.52. From this you can subtract 1.2, then you will get the answer. Okay, fine. Just copy this. Is it copied? Okay, fine. Let us move to the fourth numerical, children. So in this fourth numerical, it is a power rating related. So as per the numerical, you also can see on the screen, it is given that the power rating is 1500 watt, 250 volt. And they are saying, they are asking us to calculate the safe limit of current, and if it is operated for 50 hours, how much does it consume electrical energy, and also even they are asking us to calculate the cost of electricity. So children, so here power is given first, that is 1500 watt, okay, and a voltage is given 250 V. We know that first one, so we know that P is equal to VI. So from this, children, can we write I is equal to P by V? Yes, we can. So which means it is a 1500 by 250. So 1500 by 250, how much? 6. So the safe limit of current is 6 amperes. Okay. Next, they are asking us to calculate the electrical energy. Electrical energy formula is what, children, here? Power into time. But don't forget one important thing. Power must be in kilowatt and time must be in hours. So, but power is given 1500 watt, right? That has to be converted to kilowatt. How? By dividing with 1000. So, 1500 by 1000 is 1.5 kilowatt. 1.5, how many hours is given? 50 hours. So, the answer is 75 kWh, kilowatt hour. Children, this kilowatt hour only we can call it as a unit. So at the end of the month we pay electricity bill, right? We can say it's this month we got 100 units, means 100 kWh, 150 units, 150 kWh. Okay, third one, cost. So cost of electrical energy. The formula is, children, number of units into cost per unit. Cost per unit. So total number of units 75 we got. Okay. 75. As per the numerical, cost per unit is 4.2. If you can simplify, you get it as a 315 rupees. So this is how we can solve the numericals. Based on what? Current, electricity. This is based on the circuits and it is a power rating. Okay. Just copy this. We proceed. Is it copied, children? 3, 2, 1. Okay. Yes. D2. Now children, these two numericals are based on sound. So as per the numerical 5, children, try to understand. A person initially standing at a distance D, okay, in front of a cliff he is standing. He makes sound or fires a gun so that he can hear the echo in 3 seconds. So in the first case, children, let us apply the formula. V is equal to 2D by T. So speed of the sound is not known, okay. Initial distance is not known, okay. Only time is known, 3. So let us make it the equation 1. Now he moved towards the cliff by 82.5 meters. He moved towards the cliff 82.5 meters. Then he is standing there and he makes sound once again, and he can hear the echo in 2.5 seconds. Why the sound is reduced? Because the distance is reduced. So now the distance will be, total distance is d, and he moved 82.5. Then the distance from the cliff will be d minus 82.5. So in a case 2 children here, v is equal to 2 into, distance is how much now? It is a d minus 82.5 by time taken will be 2.5. Equation 2. Children, from these two equations, as LHS are equal, RHS can be equated. Okay, let us. So from 1 and 2 children, so it is 2d by 3 is equal to 2 into d minus 82.5 by 2.5. 2 gets cancelled. Do the cross multiplication, it will be 2.5d is equal to, with 3d minus 82.5 into 3 children, it is going to be 247.5. Now take this right side, take this left side. So it will be 3d minus 2.5d is equal to 247.5. It is nothing but 0.5d. 0.5d we can write as a d by 2, right? 0.5 is nothing but half. So is equal to 247.5. So get this side. So d is equal to 2 times of 247.5. It is going to be 495 meters. So the distance from the initial position is 495 meters. Now even they are asking us to calculate the speed of the sound. How? This d value, either you can substitute in equation 1 or equation 2. Okay, let us put in equation 1 only. So from this equation 1, v is equal to 2 into 495 by 3. 3 ones are 3 ones are 3 6 are 3 5s are. So 2 into 165. So it is going to be how much? It is 330. So v value, that is 330 meters. So this is how we can solve. Now come to the numerical 6 children. Here the person is standing between 2 cliffs, and as per the question he is standing near to the one cliff actually. That is 640 meters. It is given in the question. He is standing near to one cliff which distance is 640 meters and makes sound, so that he can hear 2 echoes. First echo in 4 seconds, second echo in 3 seconds later. 3 seconds later means what? The total time for a second echo is going to be 4 plus 3. It is going to be 7 seconds. You should be very careful. Now they are asking us to find the speed of the sound and the total distance between the cliffs. First let us calculate the speed of the sound by using the data where the person is standing near the near to the cliff, right? So here we know that v is equal to 2d by t. So this is 2. Let us take this distance 640 by, it is a 4. 2 ones are 2 twos are. So 640 by 2 is how much, children? It is going to be 320 meter per second. 320 meter per second. That is the speed of the sound. Now they are asking us to calculate the total distance between the cliffs. If you want to calculate the total distance between the cliffs, children, you must calculate the d2 value, right? Okay. So it is v is equal to t d2 by t2 now. So children, here v value is known. We calculated 320 is equal to 2 into d2 by total distance is now, sorry, total time taken is 2. So this is 2 ones, this is 160. So 160 into 7. So d2 is equal to 160 into 7 will be 1120 meters. Now the total distance is d1 plus d2. This is 640 plus 1120. It is going to be 1760 meters. Is it fine? So you should be very careful when later is given. If later is not given, so directly you can take 3 seconds only here. But as later is given means 4 seconds, later 3 seconds. So 4 plus 3 the 7 seconds time is taken to hear a second echo. Okay, copy it. Done? Okay, fine. Degrees Celsius. As per the question, children, in a vessel, 150 grams of water is taken, which is 30 degrees Celsius. They are asking one question: how much amount of ice is needed to bring the water from 30 degrees Celsius to 5 degrees Celsius? The question seems to be simple. Of course, we will make it simple. Here one important point is given. They gave even the specific capacity of the vessel also given. Which means what? As a specific capacity of the vessel is given. Which means what here? Yes, we need to calculate the heat lost by the even vessel also. So here hot bodies are how many? Water plus vessel also. First let us calculate the heat loss by the hot body, two bodies, then heat gain by the ice. So based on the principle of calorimetry, we are going to solve this. First, children, so let us calculate the heat lost by the vessel. So we know that is a mc delta T. So mass of the vessel is given 100 grams. Okay. Specific capacity given 0.4. Fine. Delta T, change in temperature. Children, you may get one doubt, sir. The temperature of the vessel is not given. The temperature of the water only is the temperature of the vessel. So that is 30 degrees Celsius. So 30 to 5 means what? 30 minus 5 is how much? 25 degrees Celsius. 25 degrees Celsius. So if you can simplify this, how much you will get? So it is 25, 0.4, right? It is a 2 by 5. Yes, so this is going to be 1000 joules. This is the heat lost by the vessel. Okay. Now heat lost by the water, children. Okay. So it will be same formula, mc delta T. Mass of the water is 150. Specific capacity is 4 by 4.2. Change in temperature same, right? It's a 25 degrees Celsius. So if you can simplify this, how much you will get? It is I think 15,750 joules. So this is a total heat lost. So total heat loss means QV plus QW, that is 15,750 plus 1000. So it is going to be 16,750 joule. Okay, this is keep aside. Now this is a heat loss way. Now we are adding ice, right? As you can add the ice, it will melt. Means it absorbs some heat, which means that heat gained by the ice we need to calculate. But here one important point you need to be noted here. We need to note. Let us say it is the let the ice required is a m grams. Usually we expect ice at a 0 degrees Celsius. First it will convert into water at a 0 degrees Celsius. Children, the resultant temperature must be 5 degrees Celsius. 5 degrees. So already 150 grams of water is there, and here some amount of ice is going to melt, right? That temperature also increased to 5 degrees Celsius. So it is from here to again to the 5 degrees Celsius. Now for this entire process, how much amount of heat is required? We need to calculate. Now here to here, there is no change in temperature, only change in state. There we can use Q1 is equal to M into L. So L value is given, that is 336. So here 336 into M joules of heat requires to melt. But that temperature has to be increased to 5 degrees Celsius, right? So here let it is a Q2. mc delta T. M value is not known. C is what? Now it is water, right? The specific capacity of water is how much? 4.2. It is a 4.2. Change in temperature 5 minus 0. It is a 5 only. So this is going to be 21 M. 21 M joules. Now the total heat gained. Total heat gained is how much? This plus this. 21 M plus 336 M. It is going to be 357 times M joules. So here we got heat lost. Here we got heat gain. Children, according to the principle of calorimetry, as there is no heat loss in surroundings, heat loss with the hot body must be equal to heat gain by the cold body. So it is M into 357 is equal to this total energy 16,750. So now mass is M is equal to 16,750 by it is 357. If you can simplify this, you are going to get approximately 46.928 grams of ice is required to bring the resultant temperature to 5 degrees Celsius. Is that clear? So you should be very careful, children. In the same type of numerical, sometimes they won't give the specific capacity of the vessel, which means what? You no need to consider the heat lost by that vessel. Then this term won't be there. Right? This term won't be there. 1000 won't be there. This term. So it will be only 15,000 only. So accordingly, you will get the amount of ice required. Okay, na? Fine. This is 7th numerical. Done. Okay. Copied. Shall we move to next numerical? Okay. Fine, children. Now, so according to the numerical 8, so it is given that cold water is mixed with the hot water. Okay. So the mass of the cold water is given how much it is? Let us say M1, it is given 600 grams, whereas the mass of the hot water is given 300 grams. And it is at a temperature of, as per the number, it is given that is a 50 degrees Celsius. Okay. And cold water temperature is not given. When these two are mixed, it is given that the cold water temperature is raised to what we can say 15 degrees Celsius. 15 degrees Celsius. Then they are asking us to calculate the initial temperature of the cold water. Initial temperature of the cold water they are asking us to calculate. So don't get confused. First you should know what is delta T1, rise in temperature of cold water. When both are mixed, let T be the resultant temperature. So then delta T2 will be what? Fall in temperature. How to calculate? T2 minus T. Okay. It is nothing but what actually? Resultant temperature minus cold water temperature. Let T1 be the cold water temperature. Now according to the principle of calorimetry, heat lost by the hot body equal to heat gain by the cold body. So heat lost by the hot body is equal to heat gain by the cold body. So it is M2 C2 delta T2 is equal to M1 C1 delta T1. Anyhow, this C1 C2, because both are water only, right? Both values same, so it gets cancelled. Now M2 is how much? 300. And delta T2 is nothing but T2 minus T. T2 is equal to 50. 50 minus T is equal to M1 is 600. Delta T1 we got as a 15. It is given. Okay. So 300 ones, 300 twos. Okay. Now 50 minus T is equal to 30. So then T is equal to how much, children? 50 minus 30 it is a 20 degrees Celsius. Children, this is not answer. This is a resultant temperature. But they are asking us to calculate the initial temperature, right? Initial temperature of what? Cold water. So delta T1 is given. So delta T1 is actually 15 degrees Celsius given. Okay. But delta T1, how can we write here? T minus T1 is equal to 15. T value we got 20. So 20 minus T1 is equal to 15. Therefore, T1 is equal to 20 minus 15. Hence, the initial temperature of the cold water is 5 degrees Celsius. So this is how we can solve the numericals based on actually calorimeter. So these kind of questions seems to be simple, children, but you should be very, very careful actually. What is given? Is it given the temperature or a rise in temperature or a fall in temperature? There only you must be very careful. Okay, got it? Just copy it. Okay, fine. Our children, as per the question, it is given that a weight of some truck vehicle is given like a 1000 kgf, and initially it is moving with a 36 km per hour, and its velocity is changed to 72 km per hour in a 10 seconds. Then they are asking us to calculate the work done by the engine and the power of the engine. Children, here one important point actually. Some students, directly they will take these values, kilometer per hour, kilometer per hour. Whenever it is given in a kilometer per hour, children, you must convert into meter per second. How? By multiplying with the 5 by 18. So initial speed is given how much? 36 kilometer per hour, right? So let us multiply with 36 into 5 by 18. So you get as a 10 meter per second. Okay. and the final velocity is, final velocity is given kilometer per hour, that is 5 by 18, right? Okay, so this you will get as a 20 meter per second. Children, here weight is given 1000 kgf. Actually here we need to apply the work energy theorem. Further we must know the mass of the vehicle, but here mass is not given, but indirectly weight is given, right? As weight is given, indirectly mass is given. How? Children, W is equal to mg, right? Mg means this 1000 kgf we can write actually 1000 kg into g value. G means what? Acceleration due to gravity. So this is nothing but actually mass. So mass is given it as a 1000 kg. Now first let us calculate the work done, then only we can calculate the power. So as per the work energy theorem, W is equal to half mv square minus half mv square. So I can take half m as a common, it is v square minus u square. So this is 1000 by 2, v square 20 square 400 minus u square 10 square, it is 100. So 1000 by 2 is 500 into 400 minus 100 is 300. So this is 150000. So this is 1,50,000 joules of work is done. Now the second part is what? Power they are asking. Children, power is very simple because power is equal to work by time. Okay, work is how much? 150000. Time is given 10 seconds. Children, sometimes they will give you 1 minute or 2 minutes. If it is given in a minutes, you must convert it to seconds. So in this question, we have taken simple as a seconds only directly. So 0 cancel. So it is 15,000 watts, or you also can write as a 15 kilowatt. Is it clear? Okay. Now last numerical of this session is, as per the question is given that it is a uniform meter rule. Children, here is a uniform meter rule. Children, uniform meter rule means immediately you should get a 0 to 100 centimeters. Okay, and it is given that this uniform meter rule is pivoted or placed at a knife edge exactly at a 58 centimeter mark, where okay, it is 58 centimeter mark. Now they are asking us to take a, see, is it balanced? No, obviously it is not balanced. Then they are asking us to balance this meter rule by placing the 20 gram force weight on either of end, so that it should be balanced. Children, it is just it's a minimum common sense. 58 centimeter mark, this length is more, length is less. As length is less means as the uniform meter rule, this mass, hence the weight will be less. So this will try to tilt, as it is here, it will try to tilt in this direction like this. So to make it balanced, weight must be placed right side. Okay. So this side, this 20 gram force weight must be added. Okay. This is a diagram required. They are asking us to find the weight of the meter rule. Even mass of the meter rule also can be asked sometime. Children, as the uniform meter rule, where this weight will act? Exactly, weight will act at the midpoint, that is the 50 centimeter mark. Now this perpendicular distance is how much? 8 centimeters, and this perpendicular distance is 42 centimeters. Now here two weights are there. Let us apply the principle of moments. According to the principle of moments, so anti-clockwise moments of weights are equal to the clockwise moments. So we know this formula, W1 into R1 is equal to W2 into R2. W1 is this, let us say it is a W1, let us say this as a W2, let it be R1, and let it be it is a R2. Okay, so W1 is a 20 into R1 is 42 is equal to W2 is W only, and this R2 is a 8. Okay, now let us simplify. W is equal to 20 into 42 by it is a 8. So 4 5s are 4 2s are 2 1s are 2 21s. So W is equal to it is a 105 gram force, children. Because here a weight is given, so we are calculating weight only. That must be in a gram force only. For suppose in the same numerical, if they ask you to write calculate the mass of the meter, how? Yes, so this 105 gram force can be written as 105 grams into G value. G is what? It's in a CGS system 980, in SS system 9.8, that acceleration due to gravity value. Okay, and W is equal to, it's a M into G. This G gets cancelled. So then mass is equal to how much? It is a 105 grams. That's it. Children, these are the topmost, I can say, top 10 numericals. So, of course, you may get one doubt, sir, are these numericals enough? Obviously, no, children. No. So, first, we can have a practice with a good numericals. Then slowly, you just can have a practice with n number of numericals. If possible, we'll try to make a, one more part, like 2 to 3 parts of the top numericals we'll make. So, as it is a first part of the top 10 numericals. So, hopefully very soon we are going to upload in a, more 10 or 15 important numericals. See, by keeping a board exam in mind only we are discussing. But my advice is that children, you have to practice. Why? Because you are the one to go in, appear to exam, right? You should, face the board exams. So, whenever, see, whether you are watching our channel, some X channel, Y channel, anything, if you have any study material, okay, don't see the solution first. First, take the question, try to write the data given, think about the related formulae, then try to solve. After that only, try to go through the solution, whether in the book or in the video. Okay, children, thank you so much. All the very best.